In this lesson, we're going to take a look at how to use synthetic division to factor a polynomial completely. So our first example is a cubic function, and we're given that one of the roots is the square root of 2. So the first step in our directions is to show that x is a 0 using synthetic division. Remember, when you divide with synthetic division, if it's a factor, you get a remainder of 0. Just like with regular numbers, 16 divided by 4 is 4, with no remainder, because 4 is a factor of 16. 17 divided by 4 is 4 with a remainder of 1, because 4 is not a factor of 17. So when we do our synthetic division, we should get a remainder of 0 to show that x is a 0. If you don't, go back and check your work. You probably lost a negative sign somewhere. Secondly, looking at our note off to the right here, remember that all radical and imaginary roots, which we'll get to in the next section, always come in pairs. So this first root that I'm given here is a square root, which means negative root 2 is also a 0 of the function. And that'll come in handy after we finish our first synthetic division. So I'm going to set that up now, again using our coefficients. And we are going to divide by root 2. This is already outside the asylum. We weren't given the factor x minus the square root of 2. We were given the 0, x equals root 2. So we use the value that we're given. I know that tends to change from time to time, so hopefully you can keep all of that straight. If you see it in parentheses, you should probably use the opposite. If you do not see it in parentheses, you should probably use the value you're given. All right, so multiplying, dropping down the 1, multiplying by root 2. Here we have unlike terms, so we're just going to add them together. Multiplying by root 2, we're going to get 2 root 2 plus 2, which is what we get when we multiply the square root of 2 by itself. Adding that to the negative 2, we get 2 square root of 2. Multiplying that by root 2, we would get 2 times 2 after the roots cancel, which gives us 4, and a remainder of 0. So this is the first part, showing that square root of 2 is a 0, and then we're going to use it to factor completely. So I could go ahead and set this up as the answer, x squared plus quantity 2 plus root 2 times x plus 2 root 2, but we don't know how to factor that either. So I'm going to continue with my synthetic division instead and use that opposite root that we were just talking about, which is negative root 2. Let's put the square down there. And remember, we're not really needing that 0 on the end anymore. That's not part of the function. That would be the remainder of 0, which just goes away. So drop down the 1, multiply by negative root 2. Add these together, we get 2. Multiply by negative root 2. Add those together, we get 0. So again, our remainder is 0, which it should be, because radicals always come in pairs when they're roots. So now we can set up kind of our final factored form, actually our semi-final factored form. We need to fix it a little bit when we've got the radical. All right, so we're going to start with x minus the square root of 2, that came from this factor, times x plus the square root of 2. Now we're putting them in the asylum, so they become opposite. And then this answer here, because we synthetically divided twice, we will drop 2 from the highest power that we started with. We started with a power of 3, so this last division answer would be x plus 2. So this is the factored form of that function we were given, but we don't need radicals in our factored form, unfortunately, so we're going to have to FOIL those 2 pieces out anyway. So we get x squared, the positive square root of 2x, and the negative square root of 2x will cancel each other out. That's what's nice about conjugates. And negative root 2 times positive root 2 is negative 2. So this is our official final factored form of the function we were given. And the last piece is to list all real zeros. So make sure you answer all parts of the question as well. And the real zeros, 2 of them we got from our division, the positive and negative square root of 2. And the third one we get from setting x plus 2 equal to 0 and solving by subtracting that 2 from both sides.